So, all right. Well, we're up to 28 people, and Bob and Ginger count as 2. So that's 29, 30 people. So very good. Debbie, if your husband's there, then that's another one. So we're up to 31. That's cool. Well, welcome everybody. I guess we should get started. We were just going to kind of start the meeting with some informal chit chat. We are going to do a Cosmic Clubhouse on Friday. The topic will be on telescopes and telescope designs. So you can debate the merits of Schmidt-Cassegrains and Newtonians and refractors. And if you're in the market for a telescope and you want to ask some questions, you're going to have a bunch of people and be knowledgeable about different types of telescope designs. Certainly there will be a lot of people with opinions, and it'll be fun. We used to do the Cosmic Clubhouse meetings at Starbucks before Coffee and Cosmos, and really all it is, there's just basically a moderator, but there's not like a presentation. It's just simply a get-together. And at Starbucks, we would all just sit around a big table. We'd all get something to drink, and we'd talk about our favorite topics. And we did one on telescopes, but we did one on DSLRs specifically. Everybody who likes to use DSLRs talked about DSLRs for different things, and compared. People brought their cameras, and we got to compare Sony and Nikon and Canon and Olympus and some other things that people brought. And it's just just all sitting around talking. We share knowledge and experience with one another, and you always learn something. And it's also it's a nice social opportunity, which a lot of us are kind of missing these days. So it's a good opportunity to do that. So we're going to do it virtually. Derek is going to kindly host with the planetarium's Zoom license. So anybody that wants to talk about telescopes, everybody will get a chance to share their screen or come on camera and talk as the need arises. And we're just gonna do it up until we all get bored and go away, or until we have to quit because of Derek's virtual star party that he'll be doing that night. Some other things that we are planning, but I don't know if we're ready to announce or not. We are going to do a CFAS star party online. So several of us have telescopes with cameras on them, and we can share our screens. And so we're going to do the same sort of thing. Hopefully there'll be a group of us who all have our telescopes set up with cameras in our backyard or whatever, and we're just going to share our screens and talk and go around from object to object. It's going to be a CFAS members only get-together. Again, just a social, sort of a star party, a social star party where we can get together and talk about our gear and ask questions and trade knowledge. And actually, I thought we did have a date for that, Derek. Do we? Let me see if I have it in my calendar.
Yes, we talked about next Saturday, May 23rd.
The Saturday, not the Friday.
Correct, because we have
you have your thing. Okay, so next Saturday night at
sunset.
9 o'clock.
Yeah, 9 o'clock.
Yeah, 9 o'clock. Yeah. When is sunset? I don't remember the day. Let's see.
The sunset, I believe, is like 8:20 something or 8.
Oh, it is. Yeah.
So
okay. So yeah, 9 o'clock. So by 9 o'clock, we'll be ready. I'll have my system set up out in the backyard. I can run mine all remote from in here.
8:13, and astronomical twilight is at 9:12.
Close enough. Yeah. By 9 o'clock, we can all start talking, and we can share our screens and see what software everybody's using. And I have limited sky. I guess everybody's going to have different parts of the sky they can shoot from their backyard. And we'll, those of us who can do live stacking and those of us who can't. And maybe even, it'll be a good opportunity to ask some questions. If you're having trouble with some software and somebody else is knowledgeable about that software. For example, the sky. I don't answer questions about our competitors' software, but if you have questions about the sky, I could try to address that while we're online. So I'm looking forward to that. That'll be fun. And yeah, so Meanwhile, I guess we should probably go ahead and kind of kick off our meeting here. Welcome to our second virtual meeting. We were just sort of talking in the pre-meeting. Nobody knows where this is going to go. We might be doing this for a month. We might be doing this for a year. Right now, the college and the planetarium is closed. Right now, most of the country is still, shut down. I don't want to debate the merits of that, but I also don't want to make any of our members uncomfortable. And we also need a really nice place where we can meet. And right now, meeting and all of us sitting right next to each other, the preponderance of the evidence and public opinion is that's not a real good idea. So we're going to stay on virtual for the near foreseeable future. It's definitely not our first choice for getting together. However, in the pantheon of hardships, this is definitely not the worst it could be for us. Okay, so let's get started. Our first mini program tonight is going to be Justin Cirillo, who is our space correspondent, who's going to tell us about the Mars Perseverance and SpaceX news and all that sort of thing. Assuming you're ready to go, Justin.
I am ready.
All right. Well, then we're ready to hear you. So
okay, sounds good.
Let's rock and roll.
Hope everyone's doing well. Good to see a good turnout for the meeting. Well, we are, 2 weeks away. 2 weeks away from a pretty exciting event. We've got SpaceX's Falcon 9 and Dragon Crew Demo 2 will be launching from Launch Pad 39A, 4:33 p.m. on Wednesday, May 27th. So if you don't already have this on your calendar, you probably want to get this added and make every attempt you can to either watch this virtually or right outside your window. So I'm going to go through the launch itself as well as the launch in July for Perseverance that will be headed to Mars. If we want to back up a little bit, you guys will probably all remember a pretty exciting day, at least it was for me, July 8th, 2011. This was just a typically miserable, hot and humid July day, but you had, I think the news said over 1 million spectators gathered along the beaches, the rivers, the causeways to watch this amazing final flight, Atlantis going to the space station and ending the shuttle program. The launch that day the weather forecast was about 70% no-go at the start of the day, but it did end up going up on time, and it had a small crew, kind of a skeleton crew, just 4 veteran astronauts. Commander was Chris Ferguson, the pilot was Doug Hurley. You probably recognize that name, or you will here shortly. There was a mission specialist, Sandy Magnus, and Rex Walheim, and they set off just mostly to it was your standard supply mission of the International Space Station, supplies and parts. Once they got up to the station, they were doing the standard backflip maneuver where they turn the glider upside down to enable the crew members on the space station to photograph the heat shield, and those photographs were sent to Houston, and they looked for any damage, and this again was of course due to the Columbia disaster. None was found, and the docking went smoothly. The return trip brought about 6,000 pounds of equipment back. These were kind of discarded items, things that were no longer needed on the station. The glider came in around 6 a.m. on the July 21st. So they were up there for a couple weeks, and Atlantis landed at Kennedy's shuttle landing facility, runway 15. And so it was kind of a bittersweet day. With that, that was the end of probably, I'd say, the most amazing for me, and some say it was the most complicated machine ever built kind of came to an end that day. So there were 5 complete space shuttle orbiters vehicles built over that period of time, over those 30 years, and flown 135 missions from, gosh, 1981 to 2011, all from Cape Canaveral. So we really had a treat watching these go up over that time period. Well, there'd be a long break between then and now, and would this be the end to American space journey? Well, of course not. We had some neighbors across the rock that were able to get our astronauts up into space, and so we would, of course, partner with Russia, and over the next decade, we would our astronauts would train and launch from Russian soil. And we were pretty dependent on Russia for this because they were the only game in town, and they were not cheap. It's $90 million for a round-trip ticket today to send an American astronaut up to the space station and back down. And over those last 9 years, we've paid $3.5 billion to Russia for this service. But monopoly, when you've got the only one that can offer this service, you can charge whatever you want. But hopefully this month will mark the end, or the beginning of the end of NASA's dependence on Russian rockets to put our astronauts up into space. So we've got 2 companies that are really on the cusp of making this happen. SpaceX Dragon Crew is scheduled to go up again this month in 2 weeks, and the cost right now is about $55 million per seat. And Boeing Starliner, you guys probably remember that, had some issues with their launch. The launch was beautiful, no issues there, but software issues prevented it from getting in the correct orbit to dock with the space station, and therefore it had to abort, come home, and it landed safely, and it's a perfectly usable capsule again. But that delayed Boeing about 12 to 18 months before it'll look like they can put their astronauts up in a test. But very competitive pricing, so a much better deal. Elon Musk was a little bent out of shape because Boeing was charging so much more, but Boeing kind of argued that this was because they also offer crew member worth of cargo on their flights, which they said brings their cost down to about $70 million. But it's all pennies, right? Last March was a pretty exciting launch. I know a bunch of you watched it. I know a bunch of you were there. Derek and I were lucky enough to get press credentials for this. Derek got some amazing images of the launch pad. I was able to get a video of the launch from the top of the VAB building. So just a really cool day. And you had, all the bigwigs were there. A lot of the government officials were there. In this image here, you can see Elon Musk talking with the astronauts for Demo 2 and Demo 3. He's there with Jim Bridenstine in the photo. You've got, and kind of next to, in the back by Elon Musk is Victor Glover. He will pilot Demo 3. And then next to Victor Glover, you've got Doug Hurley, Bob Benkins to his left or your right, Jim Bridenstine, and then Mike Hopkins. Mike Hopkins and Victor Glover will be piloting Demo 3, assuming everything goes smooth with this launch in 2 weeks. So this launch is testing the controls of the Dragon Crew capsule. It's fully autonomous. It's been to the space station before, completely autonomous, but what they're going to be doing with this particular launch is testing that if for some reason the pilots need to take any type of manual control of the spacecraft during the docking procedures, that they can do that. And so they're kind of co-commanders, Doug Hurley and Bob Benkin, on this trip, and they will both be executing several different tests along the way. And they've been at this for, gosh, pretty heavy testing over the last probably 6 months, running simulation after simulation after simulation in Houston. And if you can kind of tell from the imagery on the right there, I mean, these are veteran shuttle commanders, and those shuttles were old school dials and buttons and click this and flip that. And now everything is, you know, just this beautiful touchscreen technology. So it's a different world now that they'll be going up in this kind of sophisticated spacecraft. But these are very experienced pilots. Doug Hurley, if you remember, he was on that last Atlantis mission in 2011, and they both have piloted multiple launches for the different space shuttles. Let's see, what else? They're kind of, so we're 2 weeks away, so they're kind of going into their pre-launch quarantine right now. From probably now till I think the 20th, they will be in quarantine with their families. And then after the 20th, they will be traveling to Florida and get ready to do their dress rehearsal on the pad. I believe is on the 22nd and 23rd. They're going to be doing a static fire test on the 23rd, a launch on the 27th. And SpaceX wanted to make sure that everyone knew that they would travel to the launch pad inside a Tesla Model X, not the old school van anymore. But they've got the beautiful mission patch ready to go. This rocket is beautiful and ready. And they're going to spend about, they haven't said for sure yet, but probably 1 to 4 months on the space station. Since this is just a test to validate a lot of systems and a lot of checks and balances, it's kind of an unknown when they'll be coming home. But if this goes well, then that will open the door to Demo 3. No date is set for that yet. And Demo 3 would be full flight control of the spacecraft and docking and returning home. So May 22nd will be the day before the scheduled dress rehearsal. SpaceX plans to fill the rocket with all of its fuel, kerosene, liquid oxygen, propellants. They'll do an ignition, lighting all of those 9 Merlin engines on the pad. And this is customary. It's part of SpaceX's launches kind of campaigns are static fire tests. And then the launch on May 27th at 4:33 p.m. So assuming it's an on-time launch, the crew will dock with the space station around 11:30 a.m. on the 28th. So I think it's a 19-hour flight. They'll spend some time in the capsule orbiting the Earth and then dock the next morning. The bummer about this entire thing is that we are in the situation that we're in, and NASA is telling everyone to stay home. And these are images from the Falcon Heavy launch. Many of you probably saw this, and this is just takes you right back to those Apollo days. I wasn't born yet, but I've watched plenty of the videos to see these causeways just lined with people and driving in for the Falcon Heavy launch. It was just crazy. And so I'm not sure how this is going to go. NASA is, their last official communication was May 1st, where they said, stay home, watch it from your yard, watch it online. But no new communication has gone out yet as far as what they're communicating to the public. Since May 1st, I mean, we've had beaches open up, we've had parks open up, things like that have reopened. So, but I imagine most of the interior access locations will be blocked off by, city police and whatnot. So I would expect to probably watch the launch anywhere west of I-95. But possibly if beaches are open, you might be able to watch from the beach. But definitely the Kennedy Space Center is closed. They said it will remain closed and all of the typical areas where you can watch, like the Saturn V building, the bleachers that they have around Kennedy Space Center will not be available. So kind of start scouting out your spots now for that. But NASA has just launched today, Launch America, and this is their way of giving the public the opportunity to watch this all online, of course, you know, over the time period that it has. If you guys remember the mannequins that they put in Demo 1, I think it was something, it had something to do with aliens. It was Ripley, I think, was the dummy's name in the spacecraft, and you could literally, they had cameras live streaming this whole thing. So I got to imagine this is all going to be beautifully visible from inside the capsule. You know, you'll be able to hear the communication going back between mission control and the astronauts. So Launch America is the new website that NASA just put out today. There's a Facebook page you can go to and sign up. They're doing a NASA social event the day in, so you can reserve a seat for that and just enjoy it. Of course, most people aren't lucky like we are and have the spaceport right in your backyard, so we can just go right outside, drive 30 minutes and get a great view somewhere. But obviously, most of the world will be watching virtually anyway, so they're prepared for that. So pretty exciting stuff. Historic again. Americans going into space, not only from American soil 9 years ago, but the first time ever astronauts going into space from a commercial company. So historic no matter what. Later this summer, we've got the Mars 2020 rover Perseverance. Will be launching in July, middle of July, and Perseverance is scheduled to touch down in the Jezero crater on Mars on February 18th, 2021. And its mission is very similar to Curiosity. It's out there to look for signs of habitable conditions, biosignatures, anything of past microbial life. And it's pretty much the same technology and platform as Curiosity. You can see from the image, it looks almost identical. It's got some newer features on it, but most of it is kind of a cookie cutter of Curiosity. But there's some pretty cool new instruments on this. One of them is a new core drill, because its main mission is going to be to drill 31 unique core samples that it will accumulate and leave at a rendezvous point to be picked up on a future mission and brought back to Earth to study. So pretty cool that we're, again, just like asteroid Bennu, we're getting more and more advanced at collecting regolith from faraway places and bringing them back to Earth. One of the cool new instruments on Perseverance is called MOXIE, and it's a technology investigation that will produce oxygen from the Martian atmosphere, from converting the carbon dioxide to oxygen. So this is pretty, if this works, then this technology could be scaled up in the future for human life support. It could be used for rocket fuel for, you know, return missions. Just would be incredible if they can get this working on a larger scale. So we'll keep an eye on that. Really cool feature, though, that is not on Curiosity, that's on Perseverance, is it has 2 microphones. And so they will be used during the landing event. They will be used while it's driving. It'll be used while they're collecting samples. So we're gonna get to hear the conditions of what's going on Mars as they occur. I posted, I don't know when it was, maybe it was Monday or over the weekend. Maybe I didn't post it on the CFAS page, but I posted it somewhere. They just released InSight, the lander that is surveying the Martian planet, and it's got a seismometer on it. It actually collected sounds of 2 different Mars quakes. that it recorded the sounds, and they just published those sounds recently. So check that out if you get a chance. You can actually listen to what a Marsquake sounds like. There's 23 cameras on this thing, so the imagery that it's going to bring back is just going to blow away everything we've seen from Curiosity so far, and you know that Curiosity has brought us some awesome pictures, so I can't wait for that. And again, it's drilling these 31 different core samples, and so it's going to pull all these together and use them to, again, give us more detail on what to expect here. And I'll go into a little bit about where it's landing here next. The Jezero crater, it's kind of on the perimeter of Acidius Planitia, and this is a pretty good impact basin. It's about 930 miles in diameter, and Jezero crater sits just kind of on a delta. I've got a better picture in the next slide, but an ancient water delta. You've got Cerritos Major there to the left. That's a beautiful kind of extinct shield volcano, and that formed after the basin. But the thing that made this the chosen site for the landing site, and there was, you know, a dozen options, was this around this Acidius basin is a lot of magnesium carbonate that was found by the Mars Reconnaissance Orbiter, and this mineral really indicates that water was very abundant and that it was not acidic. The pH conditions were more favorable for the evolution of life. So that's really was kind of the nail in the coffin to choose this as the final site. Jezero crater is about 30 miles in diameter, and really what they're hoping to find is that you know, the are filled with carbonates, hydrated silica, and these are the things that we know preserve microscopic fossils on Earth for billions of years. So they're really feeling confident that this is going to be the right spot. So this image is a little bit better. This kind of shows, this is from the Mars Reconnaissance Orbiter, and that diameter there kind of gives you an idea of where it's going to land. And the software, the camera technology on this is, they've said, you know, 10 times better than what they had before in previous landings. Their ability to pick a specific spot, survey the ground conditions, and determine, because it's all automated. There's this 7 minutes of terror where it comes into the atmosphere at 13,000 miles per hour. There's no help from anyone on Earth. It has to read, survey the land, and determine the most appropriate landing site. But they've been able to scale it down to 10 kilometers or less, where before they had a huge open window to land the previous rover. So they've gotten a lot better at that. But you can kind of see the delta here. And this area, they believe, was just constant water presence, not kind of coming and going. It was a flow that lasted for, you know, billions of years. So this is just a prime spot for it to land. It's got a really cool friend joining it on its journey, and this is a Mars helicopter called Ingenuity, and it's about the size of a mosquito in Florida, maybe a little bit smaller, but it's pretty cool. This is going to be connected to the underbelly of Perseverance, and Perseverance will kind of lower it down to the regolith. It weighs about 4 pounds. Its chassis is about 5 inches, just to give you an idea of scale. The rotors are something like 48 inches in diameter, and the height is 31 inches. So it's a little guy. But this robotic helicopter essentially it's planned to be used as the test technology to scout interesting targets on Mars within that crater and help kind of plan the best driving route for not only Perseverance, but future Mars rovers. And it's expected to fly, I think, 5 times over 30 days. So not a lot, but in that time, it'll go, anywhere between, they said maybe up to 1,000 feet per flight. So it's going to cover a decent amount of ground, and all the cameras. Oh, actually, I have a slide here that has the toys on it, so you can see the sensors and cameras there. It's mostly carbon fiber built. It uses batteries that will be charged by the solar panel on the top, and just a really cool, little drone ship there that will be controlled from Earth. And I believe a lot of it is automated. It'll use some of the same surveying technology that Perseverance uses as it comes into the atmosphere to study its landing site. The same technology will be used here. So you can see in this last slide, this was Perseverance being packed up just the other day, getting packed up and ready to go into its heat shield. You can see the thrusters, those orange cones. This is the spacecraft that will drop it down on its cables, lower it down to the surface, release, and then crash land kind of at a faraway site that's safe. And you can see the little helicopter under the belly there, ingenuity of Perseverance. So really cool. So keep an eye on this for July. It's going to be going up on United Launch Alliance Atlas V. And let's see, what's the date today? So today's the 13th. This Saturday, United Launch Alliance will be sending up the Space Force's X-37B super secret spy plane. And as soon as that goes up Saturday, then they will start stacking the next rocket that will take Perseverance up. And it's second in line behind that X-37B. So the launch window opens up at 9 a.m. on the 17th. So throw you that on your calendar, and we'll watch some history be made. So pretty cool stuff coming up.
Thanks, Justin. That's really cool. I think a lot of us are going to be watching from our front yards or a nearby park and setting up our cameras and telescopes. Actually, if you have a telescope like an Altaz or something, I remember many, many years ago, it was when John Glenn went up in the shuttle. I brought my telescope out, and I actually watched the shuttle through the telescope, and I was able to push the telescope and track the space shuttle as it went up, and I saw the boosters come off, and that was pretty neat.
That would be incredible.
Yeah, much better than trying to do it with binoculars. I would not try it with the camera. There's a neural net, between your ears that can figure out how to push and track with that telescope pretty quick. But following with the camera, you're going to need some sophisticated software to do that. Actually, there is software to do that, but yeah, another thing. So cool. Before we've got close to 40 people now, probably 40 with if we throw some couples in. Before we get into Chuck's science talk, I wanted to bring up that we do have a poll tonight. And if you click on the polling, we have a poll about educational workshops that people are interested in. Nightscape photography, celestial navigation, locations for observing the night sky, and planetary imaging. And basically, we want to know which of these you are most interested in. And of course, if you are interested in something that's not on this list, don't hesitate to email one of your board members, your board member at large, or your president or observing chairman. I can see we've already got a plus on celestial navigation. And you can click on more than one. So if you're interested in all of them, just say, yeah, all of these sound great. And we'll see what we can do about that. So, all right, so I'll close that. And so our next program is Chuck Cole with our Science Activities mini program. And Chuck, are you still on? I don't see the full list in front of me. But if you can activate your microphone and do a screen share, we'll let you do your presentation. And if we can't get it going yet, we'll skip you momentarily and then come back to you if you can work it out.
I'm here.
I hear a new sound. That sounds like Chuck. Hi, Chuck.
Hi.
How are you? So you got your microphone working. How about? Yeah.
I got the video was the problem. I had everything working on the other PC, and turned out that one didn't have a camera. But I moved, and boy, I'm doing okay so far.
Okay. Well, it sounds like you're coping with it. Are you able to share your screen so you can do the presentation as well?
I've got the screen on a laptop next to this one, so I can see my presentation there. I don't know what you're saying.
You can do a screen share where you share your screen on your computer that you're on now. So if you go down to the bottom, you'll see where you can mute your audio and video, and right in the middle there's a share screen button. And if you click that, it will share your computer's desktop with everybody. So you don't have to have a camera. You can just
highlighted in bright green at the bottom.
Yeah, well, this computer does not have the presentation in it.
Okay, well then that would definitely be a problem. I tell you what, I have your presentation, and what I'll do is I will just share my screen.
Okay.
And you can.
Like I say, I've got the presentation next to me on a different PC.
Well, is there any way for you to show that to everybody?
Not that I know of.
Okay, then I'll share my screen so that you can see it, so everybody can see it, and you just tell me. It's like I'm in the back of the room with the projector, and you just tell me next slide, Richard. Next slide, Richard.
Yep. Good enough.
Okay, good. Let me share my screen. Oh man, what is all of this? Desktop one, share. Oh, I upgraded my operating system. You remember the Mac commercial? Windows has issued a salutation. Do you want to let it? You can choose quit. I might have to restart Zoom. But the new version of Catalina, it wants permission. Every time I do anything, it wants permission. It says, hey.
Isn't Windows fun?
No, this is a Mac. And the years.
Oh, yeah, okay. Here we go. Okay, many of us.
You see my?
Yeah, I see your screen.
Do you see this?
I don't see the slide again. I see the moon.
Now
I see your desktop.
Slides?
Here we go. I'm surprised at how few people seem to really know much about Russell Porter, but he's the guy that, like the slide says, he was. I think he's a greater genius, scientist, etc., than Leonardo, because Porter did it all. He was very creative. He would draw fabulous art and then proceed to make the mechanical drawings, and then proceed to go to the shop and make it, and the optical shop, and make the glass, and then take it out and do something scientific with it. Very, very prolific inventor, and very capable at every portion of optics and mechanical stuff you can imagine. But he was so prolific and good, he was invited to design most of the Palomar Observatory, and did. How do I get rid of this give subtitles a try thing that's on your screen?
Oh, I see what's going on. It's sharing on the wrong screen.
Hey, while we're figuring that out, see that photo of Palomar there on the right? The other, the former CFAS logo, remember it was an observatory?
Right.
It was modeled after Palomar.
Yeah, my artist did that.
There you go.
Are you still seeing my? Are you still?
Yeah, I got the slide now.
Okay.
Okay. Let's see. If you don't have the 3 volumes of amateur telescope making, I urge you to go to the library, check them out, and look them over. Some of you may not know this, but with Albert Ingalls was the editor of those 3 books, and the editor of Scientific American, etc. They were good friends, and when World War I came up and we couldn't get German optics and so forth, they gathered optical experts and so forth in the country, and we've started making prisms, binoculars, gun sights, etc. And there's some stuff, good stuff on Russell Porter on Wikipedia. But he always did the art, a beautiful pencil illustration, and then he would make the parts and did science. So next slide. Next slide, Richard.
I'm trying. There we go.
That's just the Palomar brochure. That they're hard to get now. I think you can still get them if you visit Palomar, but that's got some really interesting pictures of the machine and so forth. Go ahead, next slide. This is one of Porter's art things, and if you look carefully, well, here at the main focus, you can see a little bitty person. There are several people illustrated in here to give perspective of size and how you would access it and so forth. These white lines are various ways the scope can be pointed and see things. Next slide. Yeah, this is just some deep, I think this is cropped so we can't really see a whole lot. So, oh, there's somebody down on the lower right at some podium. Go to the next slide.
I see it.
Okay, now this is a detail of the mechanism. Turns out glass is not really a solid. It's kind of a slow-moving liquid. So when the scope points to different parts of the sky, the mirror tends to sag and lose the optical figure. So there is a complex set of mechanical fingers to point on the mirror and push it back into shape. And this is a detail of those that are on the back side of the mirror. Fascinating detail. Next slide. This is a picture of the observing cage at the prime focus, and you'll notice that there's a guy sitting in the chair peering over, looking at something there on the prime focus. And over to the right of this picture is sideways, but that's okay. Over to the right is the sort of a walkway or gangplank. They tilt the scope up to where this cage points to that, and the guy can come through that little gate you see and get into the chair and spend the night watching his plate. But somebody actually rides the telescope for the night of observing. Next slide. This is a picture from amateur telescope making book of the Springfield telescope that Cirillo gave to CFAS and our having that conference for AVSO was the basis for the endowment that we have. But it's pictured in one of the ATM books. And those were size inscriptions on that particular book. Next slide. This is a typical illustration of what Porter would do. This is from figure 31 in one of those ATM books, showing a person using the Springfield scope. Springfield is an interesting thing in that the eyepiece stays put, kind of like looking through a microscope, no matter where the scope points in the sky, which had a great deal to do with why Cirillo recorded so many observations. Like he recorded way over 100,000, but his first certificate from AVSO at Harvard was for 100,000 observations. Anyway, made on that scope that he gave us. Next slide. I thought I knew a lot about Russell Porter, but just the other day in the Amateur Telescope, Antique Telescope Society, a guy I know posted a comment that Porter had also created the optical comparator used in machine shops that allows you to measure things to 10 millionths of an inch. But note that Leonardo he did not make or use the things that he drew. His job was to make things that could be made by the military and so forth. But apparently he didn't know how to make these things. There's no evidence he ever did. And that's the real contrast between Porter. Porter did it all. He'd start with a conceptual drawing showing how people would use it, go on and make the parts and do something with it. Well, that's really all I wanted to show.
Okay. Thanks, Chuck. And for anybody who feels awkward with computers, the president of the club, who's a professional software engineer, can't figure out how to share the right screen. So it's not just you. Not just you. So thanks, and thank you, Chuck, for being a champ. And next month, maybe we can try sharing the screen on your computer. We'll get the slides on the same computer, and we're all learning as we go along here.
I probably could have done that if I'd taken more time, but I had enough mysteries to solve just to get this far.
I understand. Well, kudos for you for overcoming those. Next is Derek, who I hear we have had quite a few astrophotos mailed into him. We have had quite a nice little spout of nice clear weather.
Yes, so I was reading about the potential of La Nina this year. Frank and I were talking about a little bit of that about a couple days ago. But yes, there's a chance that we may actually have some really nice, dry, clear air for a while. However, the problem with that is that there's a chance that we may have more hurricanes. So, 2020 just just keeps giving.
That's fine. No power means darker skies.
True. As long as anyways. So yes,
Priorities.
You're right. Priorities, exactly. But yes, we have some really nice images, and of course, just like any of the astrophotography showcases that I do, we kind of go in a nice progression from planetary to deep space. So if you see your photo and you are here, you can go ahead and unmute yourself and just mention a little bit about what your photo is, what you've taken with it, things like that. So let's get started here with our presentation. Of course, I have to start it myself, so let me go ahead and do that here.
Ha! Derek can't share his screen either.
No, it's just I have 3 computers running at once, and I can't remember which one I'm using right now. All right, so here we go. All right, so this one's my photo. We're going to start the moon. This was taken right around first quarter moon, a little bit early. And John Pinto, John gave me a really great idea of annotating moon things. And actually, I have discovered that I'm not only a visual learner, but a kinesthetic learner. And I find that when I actually create these things, I actually learn better. So it helps me a lot to annotate these craters and maria and valleys and things like that in here. So I wanted to kind of show you all some of the locations. As you can see, we have several maria in this picture here. We have the Sea of Serenity, Sea of Showers, Sea of Coal. We can use the mare, Serenitas and things like that, but it's just easier to use the English terms. And of course, we have, this is my favorite crater. Yes, folks, the Lake of Death is on the moon. But anyways, I thought this was a nice shot here, seeing the contrast. You can see the details on these, on the Caucasus Mountains here on the moon. Now, actually, the next photo is actually a zoomed-in shot of Plato, and this image is from Bill Costring. Is Bill here tonight?
He was earlier.
Bill's here.
Bill is here?
Yeah.
Bill, would you mind sharing a little bit about this, about some of the technical details of your photo?
Can you hear me now?
Yes.
We can hear you.
Okay. I was trying to unmute and it wouldn't do it. I really like that Archimedes in your photo there, actually. That looked really good. This here was a 1-minute video I took of Plato. And it actually came out a lot better than I thought it would. Scene was not all that great that night, but for some reason the lunar photos came out real well. And I've always liked Plato. I stacked, I think, 20% of the frames and processed it in Registats. So that was about it.
Yeah, Plato is such like a smooth crater with very little cratering inside of it. It's just a nice bowl. And these mountains that we see here along the edges here and the Valles Alpes here, it's a very nice contrast, Bill. Great job on that. All right, I believe this is also your photo, Bill, right?
Yeah, that was from the same night. Also still a 1-minute video with 20% stack and processed from Registacks. Came out real nice. I like the Plato and this one here, the best out of them all for that night that came out real well.
Definitely. Yeah, no, it definitely makes you feel like you're orbiting around the moon there. It gives you a feeling of three-dimensionality, especially during that lunar phase. All right, this is Frank Kane's shot of Jupiter. Frank?
Yeah. So the story behind this one is I got a deal on a Celestron 11-inch from the NEAF conference that got canceled. So it was kind of a fire sale for the units that they couldn't ship at the conference. And a few days after it came in, we actually got really lucky with a morning of super clear seeing on May 5th. And I just got up at 5 a.m. and Jupiter was just still. Like, it looked awesome. It was like a holy moment, you know? So I took about 180 seconds of video of this thing. This is like the best 10% of those frames, stacked and sharpened in Registaxed and sharpened a little bit more in Photoshop. And you can see a ton of detail there. Really like it.
Yeah, no, this is great. Seeing is king for planetary viewing, and when you have those moments in any night, you take that opportunity. There's a few and far between to have such great seeing conditions. So that's great. And the detail of the Great Red Spot here is truly, truly nice. You can actually see the outer band here that's forming around it, which is really rare, which is really hard to get with the spot.
Yeah, I got lucky with the seeing that morning, and unlike Bill, I do not make my own luck through skill. This is pure luck. So,
well, some of us can challenge that, but yes, but either way, it's a really nice picture, Frank. Thank you for sharing that. All right, so our next photo is this is from Fritz. Fritz did a great shot of the Owl Nebula. Here, M97, a little planetary nebula in Ursa Major. I kind of see, the way I see the owls, it's got the two eyes and it's kind of the beak. That's how I see it anyways. He took that with his 8-inch Ritchie Crichton telescope on a Losmandy mount. And I believe he's using the same camera you're using, Frank. Is that right?
That's right. The ATEC 383L Plus.
Yeah, he's using the ATEC 383 Plus. Yeah, so a monochromatic camera and multiple filters there. So, but yes, so as you can see, we're moving into deep space images here. This is a shot of the Lagoon and Trifid Nebula. This is a picture I've taken. I went to Chiefland a few weeks ago. Chiefland, by the way, is a great place to go right now because I was the only person on the field. I literally was the only person on the field, and we're great, nice and dark, just good transparency, good seeing that night. And I wanted to get a shot of both of these. A lot of times when you see photos of the Lagoon Nebula, a lot of this is blown out or very bright, but actually there's a lot of very intricate detail in here, and there's a lot of different color layering here. So what I did is I did this as an HDR image, took several different exposures and blended them together to get that almost three-dimensionality of the lagoon. Again, there's not just a bunch of hydrogen gas there's tons of other elements as well. So I wanted to provide that detail in there as well, a lot of dust and other stuff. So again, wanted to provide that data. Of course, here's the Trifid Nebula here, the nice blend of the emission nebula with the reflection nebula. This was taken with a William Optics GTF 81 refractor with a cooled Canon 6D camera and an Atlas mount. So this was quite a long amount. I think it's 40 times 5-minute exposures for this image. All right. Moving along, this is a recent image I took actually a couple days ago at the Geneva campus. We had a CFAS member ask me if we have access to the Geneva campus. Unfortunately, as an employee of the college, I was able to get access to Geneva to use as a observing site for me, but unfortunately, we're not allowed to have a large group together. But what I would like to do maybe later on during my night sky tour is I'm going to show you all some of the new sites that I've recently discovered where you can go out and set up a telescope. But here we have SN 2020 JFO. This is a newly discovered supernova. This supernova is a Type 2 supernova, very, very bright. As you can see, compare that to the core of this galaxy, extremely bright. Of course, this is a spiral galaxy, so we tend to see a lot of supernovas happening in this area or in this galaxy because of its very fast spiral arm rotation, which usually generates a lot of motion. And these stars in this galaxy don't last very long. This is a starburst galaxy, so you tend to see a lot of supernovas in here. So interesting, we got a chance to see that, some live action. This is 55 million light years away. So as a fossil hunter, I like to tell people that this supernova occurred when Florida was underwater and there were prehistoric bus-sized sharks ready to eat you during the time the supernova actually occurred. So kind of fun little way of giving perspective of some of these events. Even though we see it today, this happened a long, long time ago in a galaxy far, far away. Anyways, I believe this is Leonard's shot. Leonard, this is his M101.
Yes, M101 at a mere 21 million light years away. I shot this out in my yard and using the 120 millimeter Esprit telescope from Skywatcher and my Orion Atlas mount. The camera's the ASI 071 one-shot color. Using 5-minute exposures, I gathered just over 2 hours worth of data and then processed it all in PixInsight. That's about it.
Yeah, no, your colors are looking much better, Len. Seems like your processing skills are becoming more masterful. So
my
really
my first post on this was just quick. It was at 3 a.m. I started processing it, and I was just roughing things in, and I went ahead and posted that picture. But then the day after, I went back and did all of the processing over again, and I noticed that it was real weak in intensity. I have a tendency to not brighten them up too awful much until I see them after posting them.
Right.
Hardest lesson to learn: don't post until after you've slept.
Yeah.
Yeah.
All right, great. Okay, our next image is Frank Kang's M51.
Oh, I didn't know you were showing this one. Yes, that is M51. Yeah, that was taken using my usual rig, the ADIC 383 L Plus camera on the Paramount Mighty and a Skywatcher 190MN. Basically, I've tried like imaging this same galaxy every year since I started imaging and seeing if I can tease more detail out of it. The answer is no. Like, I think there's only so far you can go with suburban light pollution, but hey, it's still pretty. It's a galaxy. It's two galaxies, actually. How cool is that, right?
Exactly, yes. One galaxy absorbing another in constant battle. Our Milky Way and Andromeda will eventually be experiencing those things there.
Yep.
This is the Sunflower Galaxy from Fritz. Again, same camera, same telescope setup. Beautiful, beautiful spiral galaxy there. And I believe this is our final shot. This is Frank's
M106.
M106, yeah.
Yeah, same gear as before. This puppy's about 23 million light years away, as I recall. And only about 4 hours of exposure time on this one from suburbia. So pretty happy with the amount of detail we were able to pull out, given that relatively short exposure time from a pretty badly light polluted environment. Although honestly, the light pollution does seem better lately for some reason. But yeah,
definitely, I think so. It's also been very dry. It's also been drier too. The humidity has been lower, so less water vapor in the atmosphere too. Yep. That helps a lot as well. Even though light pollution has been down a little bit, I've noticed. So pretty cool. And I believe that is it for Astrophotography Showcase tonight. So yeah, again, be sure to keep collecting those ancient photons and send them to me, and we'll be happy to showcase them going forward.
Yeah.
Derek, we had one question during the presentation. Mike was asking about the ability to capture swan at all with the cameras and the telescopes.
The answer is yes. Currently, swan is a naked eye object. It's below 5th magnitude. However, the issue is that it's very close to the it's in Pisces at the moment, which means that it's very low in the horizon right before sunrise. So you're competing with the twilight, and that, of course, is going to affect your ability to image it. However, hopefully what's going to happen is that as it passes perihelion, hopefully, if the comet survives, we'll start to see it in the evening sky, and we'll eventually start to move further away, and we'll have more and more time. However, if you're in the southern hemisphere, you're going to have a little bit better luck because you're moving into winter, and Pisces is a little bit higher in the sky, and you'll have a little bit better chance of catching the comet at the moment. But yes, it's possible. The other issue you're experiencing right now is that the moonrise will be happening around the same time. So you're competing with twilight, a bright moon, and anything else that gets in the way of it. But it is doable. Definitely try it out. It's going to be very low in the eastern horizon, right before sunrise.
Yeah, fingers crossed. And Derek's going to talk a little bit later about some sites that he's dug up. So maybe when it comes around the sun, those are some good places where we can go and image it away from, downtown Orlando or Lake Mary or Sanford or whatnot. Okay, so our next program, I'm actually up next. I'm going to share my screen. Let's see if I can do it correctly this time. Everyone should see the moon. And I am going to talk about our monthly Astronomical League observing programs. And this month's observing program, I chose the Constellation Hunter because this program does not require a telescope at all. You can go out and see and learn the constellations naked eye using this program from the Astronomical League. And when you complete the program, you get a little pin that says, "Hey, I actually found the constellations, and I did not use a computer to tell me where they were, to get my telescope where I needed it to be." The requirements are pretty simple. Equipment-wise, you just need your eyes, and you need to be an Astronomical League member, of course, which everybody in CFAS is one. And you go out and you basically you learn the brighter stars and the brighter constellations. I think this is an excellent exercise, even for some of our old timers to do. I really think I should do this myself. I've gotten, when I started as an amateur, I was pushing a telescope around and finding things and star hopping, but I've gotten very lazy with, telling my computer, slew to NGC, blah, 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 blah. And it's like, what constellation is that in? I don't remember. I shot it when it got dark, and it ran all night, and I woke up in the morning and I had data. So this is an astronomy club. We are actually amateur astronomers. So this is a good way to learn the night sky in a nice structured and organized method, and to get some recognition for it, and brag to your fellow club members that you passed the test. Some optional equipment, a planisphere of some sort. You can, of course, find. There are so many free sky charts online. I really almost want to say, if you can't find a free sky chart at www.google.com, you're probably in bad shape. Sky and Telescope has one. Astronomy Magazine has one. That's skyandtelescope.org, and of course astronomymagazine.com. They have interactive sky charts online, so you don't have to buy anything at all. But a planisphere is a nice thing to have. You can take it outside and use a dim light. It doesn't even have to really be a red light. We're just looking for bright stars and constellations. A dim light will be fine unless there's somebody around you doing observing that you don't want to mess up. But this will help you find the constellations that are in the list. Now, one of the things I kind of want to start talking about more with the club, this is a good way to sort of introduce recording requirements. Back when I started as an amateur astronomer, I kept an observing log, and I still have my old observing log, and it doesn't even have to be real formalized, but this is a good way to get used to some formalized observation, keeping track of your observations. So for this in particular, you need to write down your latitude and longitude, which as a good amateur astronomer, everybody, and today's modern smartphones, you should be able to find your latitude and longitude fairly easy. Also the name of the time, the name of the constellation, and learn how to gauge sky conditions. Transparency is the clarity of the sky. It's sort of a measure of how hazy things are. Seeing is the stability of the sky, how much are the stars jumping around or how much are the stars twinkling. And you need to sketch the stars or sketch the constellation. This is not a sketching contest. I forgot. I was going to find some of my old sketches just to show you so that you don't need to be embarrassed. If you can just basically draw some stars in roughly the pattern that the constellation is, the more times you do it, the better you'll get at it. And it's a good way to sort of formalize your observing program. Once you go through the constellations, there are, I forget how many, I thought I had it listed. Oh, there it is. Oops, there it is, 39. So you need to make 39 observations of the northern hemisphere. And I have a sheet, and I'm going to share it via the chat room when I'm done talking, so you can get the list of all the constellations and start working down. You're not going to be able to do it in one night. This will be a month, a little bit of a long-term project, but you can take some pride and satisfaction from the fact that you have at least once found these bright stars, so you're familiar with them and where they are, and you know what the constellations look like, possibly from a light polluted area, but if you just find a few of the stars and sketch out the main area. Also, okay, so that kind of wraps up. Oh, somebody's got a lot of feedback. Somebody, it's okay, it's gone now. Observing. Derek is our observing chair, and I've talked to Derek, and Derek is going to start issuing a monthly observing challenge, and he's going to wrap that in with his night sky tour to show you where the objects that we want you to observe and record are. And the purpose of this is to get you used to making observations and recording them. This is the Amateur Astronomy Club. And if you just want to do this to relax, it's a great way to do that, but also to keep a record of what you've done so that you can feel some pride in your accomplishments or to share them with other people. If you do decide that you want to start making scientific observations from one of the many scientific organizations that actually ask for contributions from amateurs, this is a good way to, it's not going to train you for a particular observing program, but it is a good way to start to get you into the habit and to give you some confidence in just making some simple recordings. So we made up a CFAS observing log, which consists of a big circle where optionally you don't have to draw a photo. You do not have to be a skilled sketcher, and you don't have to do it at all. But you can record the target, what you're looking at, the date and the time, the telescope, information about the eyepiece and the magnification that you're using, and to write some notes down. Again, I want to tell you that the seeing is just atmospheric stability. You can watch the brighter stars and see what they're doing. Many of the formalized observing programs have many grades of seeing stability. I think it's good enough for a beginner to just figure out between good, fair, and poor. If everything is really stable, you can tell that it's really stable, and you can mark that as good. If it's really terrible, you can mark that as poor, and if it's somewhere in between, you mark it as fair. And there's no way for you to learn how to discern that except by experience observing things through a telescope. The moon's a really good example. The more you crank up the magnification on the moon, the more turbulent the area gets. Bill was talking about his photos of the moon, talking about the seeing being so bad. And that's why when we do lucky imaging, we'll take thousands of images with a high-speed camera and only use, say, 20% of them. There are moments where the atmosphere is very, very stable. It only lasts for a fraction of a second, and we catch those. And we only catch a few tens or a few hundreds of them over the space of several minutes, but the software will help us go through and pick out those nice sharp frames. Well, that doesn't just apply to imagers, that also applies to visual observers as well. How well can you make out the details on the moon or on the planets, or count stars in an open cluster or a globular? You need good seeing to do that. And so that's an important thing that needs to be recorded when you're doing your observing. By the same token, transparency, keeping track of that, that's the clarity. And again, good, fair, and poor, I think, is fine for getting started. There are different observing programs where they have up to 10 different levels of transparency, and you can learn to be, refine that to a very high degree. Telescope magnification, to compute that's a very easy math problem. You just simply divide the scope focal length by the eyepiece focal length. So that would be, usually that's in millimeters. So if you've got a 1,000 millimeter telescope and we'll make the math easy, 100 millimeter eyepiece, then it would be 10x. A 50 millimeter eyepiece would be 20x, and so on. So optional things that it would be good for you to record, but you don't necessarily have to feel like you should. Sketch the objects if you dare. Just kind of, if you're looking at a beautiful open cluster, just draw in the stars, how you see them, and start doing that. We're not going to require latitude and longitude, but it's an important thing in a lot of observing programs. And as amateur astronomers, we should be able to tell what our latitude and longitude is. A lot of observing programs also will have tests. Can you convert local time to universal time in your head? So if you can record the time, actually I recommend you record it both the local time and the universal time for where your observations are. And so I'm also going to post this on the chat. I can share files, so I'm going to drag over two PDFs for you. One is the CFAS observing log, and one is the constellation and bright star list from ALCOR, if you want to participate in that program. And every month, we would like for you, if you meet our challenge, we would like you to submit your results to our observing chair, who is Derek. And we want to recognize our members who are actually out and doing observing during the month and doing astronomy. And we think that that's good for the individual, and we want to recognize them and encourage them to continue along that path. I mean, that is, after all, what an astronomy club is all about, right? It's not just coming and listening to lectures. We could just watch YouTube for that. We need to be here for each other in a certain way and provide you with some framework on your path to becoming a better and more competent amateur astronomer. And this is one of the ways in which you can do that. We can help you help yourself by becoming more active in observing. And who knows, after you get used to doing it with the CFAS monthly challenge, you could start doing ALCOR programs, and before you know it, you'll be going to star parties and giving lectures about your favorite open clusters. So that is it for that. I'm going to unshare my screen now, and I'm going to go find those files and drag them over to the chat box where you will be able to download them while Derek does his night sky tour, and he's also going to introduce the targets that are the CFAS challenge this month. So take it away, Derek.
All right. Thank you, Richard. Okay, so right now we are currently looking at, the time is 9:54. So astronomical twilight is pretty late right now as we get into the summer months. The date obviously is May 12th. Technically we're May 13th, so not much difference between each day. But what we're going to do is, of course, one of the first targets we want to look at is we're going to be moving over to the southwest, over to the western sky. And we're going to see, we're actually going to go back an hour. And we will see right here up in our sky is the planet Venus. So Venus is starting to get closer and closer to the sun, and eventually will be coming over into our morning sky later this year. But interestingly, as well as Venus is getting larger in the sky, or in this case, brighter. And if you actually were to take a picture of Venus for the last several months, Venus would have grown about a couple of about half arc minute in the sky. So quite a change in the size of Venus. But of course, the phase of Venus is getting more and more crescent rather than what we had earlier this year. So definitely take a look at Venus. That's actually my first observing challenge. My first observing challenge is the planet Venus. So I would like for you all to, while it gets dark, you can actually see Venus during the day. If you have a go-to mount, you can actually view Venus during the day. It actually freaks people out. When we do outreaches, we look at Venus during the day, and we tell them we're looking at another planet, and they don't believe us, and then they look through the telescope, and lo and behold, they see a planet. So this is a good challenge. So get out there. If you have fairly light blue skies, this is a great one to start off with. So my first observing challenge for this month is the planet Venus. So go for that one. Of course, we're going to see the bright star Capella here. Capella is located in Auriga, the Charioteer. What I'm going to do here is bring up some constellation lines. Auriga makes up this kind of pentagon shape here. If you are lucky enough, you might be able to catch some of the star clusters kind of distributed through Auriga. But unfortunately, it's getting pretty low in the sky. And depending on your clearance, you might have a lot of trees in your neighborhood, might not be able to see that. Same goes with Orion over here. You might be able to catch Betelgeuse before it gets too low. Interestingly, Betelgeuse is getting brighter again. It's pretty much now at its normal brightness. So its variability has come back. And right now we think the reason why Betelgeuse got very dim is because of excess hydrogen gas that surrounded the Betelgeuse. Kind of almost made it almost like imagine having a fire and having smoke around it has slowly reduced its brightness because of that excess hydrogen gas that's being blown off of the star. It is becoming quite unstable. So it's only a matter of time before Betelgeuse, or it could have, starts to implode and eventually explode as a supernova. All right, so some of the things that you will be able to see as we get into later in the night, you'll be able to see the stars Castor and Pollux. These are the two stars of Gemini. Of course, we have Castor here, and we have Pollux. And down here at kind of the foot of Castor is a really nice star cluster to look at, M35. So you might be able to catch that right as it's getting dark. Open clusters are still okay to look at when you don't have completely dark skies. But really, this time of year is the season for galaxies. As we move away from the galactic plane of our galaxy, we look into intergalactic space, and we can start seeing galaxies. And the things that are going to be really exciting this time of year are near the zenith of the sky. If you look towards the top of the sky here, I'm actually going to go to end of 9 o'clock. Near the zenith, you're going to see our really nice constellation here of Leo the Lion. So I'm going to go ahead and put the names of these constellations here. So we have Leo the Lion here with the nice bright star Regulus that makes the heart of the king. And then we have the back star here, which is Denebula. And then his back is Jojma right here. We also have Algeba, which is the neck of Leo. So here we have the head of Leo with Regulus, and the back and the tail. And there's a couple of things we can see in Leo is that if you go here between Zosma and Shertan, which is the name of these two back stars of Leo, and you kind of head this way, we have the nice, what we call Leo trio. So I'll pick M65, which is part of that Leo trio. And of course, if we zoom in on this area, we can see M65, M66, and NGC 3628, also known as the Hamburger Galaxy. So if you have a fairly wide field view, maybe a small refractor or a reflector, you might be able to catch all three of these galaxies in your field of view. But of course, if you have a larger telescope or higher magnification, you'll be able to see these three galaxies here. Again, this is a great target to get this time of year. So those are some of the objects that I recommend to look at in Leo this time of year. But of course, down below here, if we continue going towards the east, what I like to do is head to the north first, because I want to point out a very famous group of stars right here. You can, of course, know what I'm looking at. Most of us are polar aligning our telescopes to Polaris right here. And of course, we use the two stars Merak and Dubhe, the two pointer stars of the Big Dipper. Of course, this is the Big Dipper right here. And of course, Ursa Major, the Large Bear. So, of course, we have these three bright stars here, Alioth, Mizar, and Alkaid. These three stars basically point over to, they almost kind of arc right here, and they arc over to Arcturus. And Arcturus is the main star in Boötes, or as you can see here, it looks like it says booties. So don't be that person and go, look, there's booties in the sky. You just don't want to do that. You want to call it Boötes. And this is the herdsman here. We got a nice bright star here called Izar right there. And Izar is kind of the belt star. Boötes kind of wears a belt too. And located in this area of the sky, just a little bit north of it, is my next observing challenge. Yes, folks, my next observing challenge. Oh, I was a little off, sorry. I was thinking of another galaxy. I had them mixed up. That's okay. I was gonna head this way anyways. We're actually gonna go this way, down here towards Virgo. We're gonna arc to Arcturus using the handle of the Dipper. Then we're going to speed down to Spica. And Spica is the main star in Virgo. And many of these stars in Virgo are very dim, very hard for us to see unless you're under a dark sky. But once you find Spica, you're kind of in Virgo. And all throughout Virgo, we have a lot of different clusters. But my next observing challenge is M61. Why do I want you to look at M61? Well, I want you to look at M61 because there is a supernova going on right now. And you can, in your sketches or in your photography, you can mention that. So again, galaxy, barred spiral galaxy technically, and located in the Virgo cluster. So this is one of those many galaxies, but there's tons of galaxies that you can see in this part of the sky. For example, we can also take a look at, keep hitting the wrong buttons. What did I do? There we go. There we go, M84. All right, in this part of the sky here, we can see what's called Mercurian's chain. This is a wonderful part of the sky. Again, also located in Virgo. M84 is part of this whole group. We have M86, M84. We have, well, I guess it's not identifying these guys. We have the eyes. This is NGC 4438. We got all these different galaxies, from lenticular galaxies like this one here, to elliptical galaxies, to spiral galaxies, to barred spiral galaxies, to everything in between, all in this part of the sky. So you could literally point your telescope at one galaxy and slowly move it to all of these other galaxies. Now, you need fairly dark skies to see a lot of these galaxies, which is not part of my observing challenge for this week or this month. But either way, definitely take a look at the Mercurian's chain of galaxies. again, located in Virgo. And what you want to do is, again, know where Spica is and kind of look for the neck of Virgo and go up. Another way you could find this is if you look for Denebula here, the triangle of Leo makes an arrow marker, and essentially you take this star in Virgo here, which is the kind of right arm of Virgo, and you basically go in the middle of that, and essentially you make your way towards the great Virgo supercluster. This pretty much whole area of the sky is littered with galaxies. You could literally survey this entire part of the sky and find all kinds of galaxies. All right, so far we have 2 observing challenges. We have Venus, we have M61. Another observing challenge that we're going to talk about a little bit later on, not yet, is we're going to go ahead and show you all another galaxy. This is not part of the observing challenge. I just want to talk about it. Just below Virgo, heading to this little constellation called Corvus right here, kind of makes a diamond shape. By the way, Corvus to me looks like a baseball diamond. We have home base here, first base, second base, and third base. If you take these 2 stars, the second base and third base, and you head towards Spica, about 1/3 of the way, you go up from it, you eventually arrive at what we call the Sombrero Galaxy. Yes, the Sombrero, or as I call it, the UFO Galaxy. This is a beautiful spiral that's looking edge on, a very nice defined spiral galaxy there. So this is a great target to look at, even with a fairly small telescope as well. So again, take a look at that. Again, it's located in between Virgo and Corvus. Now, as we continue along, what I like to do is I'm going to go ahead and bring up a, I'm going to bring up another object, M3. And M3 is my next observing challenge. Yes, folks, we have a galaxy, we have a planet, now we have a globular star cluster. So M3, I would like you all to observe this. This is a beautiful globular cluster. Globular cluster are basically big, large fields of stars that are in a galactic halo surrounding our Milky Way. These are home to stars that are as old as 8 to 10 billion years old. And you can see most of the stars in these globular clusters are orange, which suggests that these are older, cooler stars, much older than our sun. So again, take a look at that there. We have the third of the observing challenge objects. And let me just make sure I have the other 2 here correct. As I said, like Richard, it's been a long day. There we go. Okay, great. Yes. Okay. So that is the third challenge, M3. Now, speaking of Ursa Major, we're going to go back down. You can see here we have several objects in Corvus and Virgo. Over here, we head towards this part of the sky. You can see there is the tail or the handle of the Big Dipper. Just next to it is this little tiny constellation called Canis Venatici. These are the hunting dogs. Basically, they're just 2 dim stars. But located near there is another group of galaxies. Oh, I did it again. It's kind of annoying, but it is what it is. It just doesn't take my keyboard. Oh, I was thinking M51. Excuse me. Again, a long day here. There we go. That's the one I was looking for. Is M51. This is that spiral galaxy that Frank mentioned or took a picture of. Beautiful. This is the Whirlpool Galaxy, a very famous galaxy, famous for the Hubble Space Telescope. Again, a major spiral galaxy that is actually consuming a neighboring galaxy here. So again, that's located just in Canis Venatici. technically it's kind of, to me personally, it's actually closer to the last star in the tail of the Big Bear. So if you find Alcade, the last star in the handle, and you head towards Canis Venatici, eventually you'll make your way to the Whirlpool Galaxy. Now, over here, kind of in this part of the sky, on this part of the side of Ursa Major, that's where we can find M82 and M81. And this right here, folks, these are your, you can pick one. These are your next observing challenges. You can either pick the Cigar Galaxy M82, which is a edge-on spiral with an active hydrogen jet system going on, or you can go with Bode's Galaxy, which is M81, another beautiful spiral galaxy. So yeah, you can either pick one of these. So again, we have Venus, M61, M3, Bode's Galaxy, or the Cigar Galaxy. Those are your choices. Let's continue on going forward. So as you can see, lots of different galaxies. There are tons of galaxies all throughout this part of the region of the sky as well. We have M101. We have various different NGC galaxies. Here we have Draco right up here. Again, tons of galaxies in this location here. Well, what we're going to do is we're going to go towards the morning now. We're going to head to pretty much near sunrise. And I'm going to go ahead and move the sky over to the southeast. And we'll see here in the southeast, we will start to pick out the Milky Way band. If you're in a dark sky, you can see the Milky Way band. Here we have this constellation Sagittarius. And all throughout here, we have the various different nebulae like M8, M20, M8 Lagoon Nebula, M20 the Trifid, M16 the Eagle, M17 the Omega, M22 a beautiful globular cluster. I have M6 and M7 here near Lasaf here in the tail of Scorpius. So a ton of stuff to look at in this part of the sky. But we reached my final observing challenge. I would like you all to either observe Jupiter, Saturn, or Mars. You have the choice. It's a beautiful time to observe all three of these planets, but I have, it's up to you which one you want to observe. You can observe the giant planet Jupiter, the ring planet Saturn, even though Jupiter has rings, but you know, you don't see them through a telescope. And of course, our little Mars, which is actually heading towards opposition later this year. In October, we'll be in the next opposition of Mars. So again, Mars is only going to get better and better and better as time goes on. Now, if you want a real super challenge, this is a bonus challenge. All right, so you don't have to necessarily do this, but this is a bonus. If you take a look, down here we have Pisces, right here. Right here we have the group right here called, and right about here in this part of the sky, you'll find a faint, fuzzy, out of focus star, and that's Comet Swan 2020 F8. That is the comet that's currently visible in the sky. And as you can see, we are looking at 525. And right now, let me just pull it up here. Let me see when astronomical twilight is or astronomical dawn. Right now, astronomical dawn for tomorrow morning. Hold on a second. Astronomical dawn is going to be 5:05. So technically, we are out of the darkest skies, but we'll still see some sunlight. And as you can see here, the sun will begin to rise. And unfortunately, you will lose it. You have a very small window to observe Comet Swan. So that's why this is a bonus. See if you can challenge yourself and observe this comet. If you get up early in the morning, you have clear eastern horizon, you will be able to see this object. And actually, Comet Swan is heading towards Perseus. At the end of the month, it should actually be in Perseus. The problem is as we move into the end of the month, as you can see here, the sun, it will get a little bit, it'll actually get a little bit around the same height, get a little bit shorter, but it's actually going to rise a little bit earlier. So you might actually get a chance to observe it later this month a little bit more in the sky. So yeah, so those are my observing challenges. Richard gave you the sheets. All you have to do is fill those out, send them to me. And next month, during the June meeting, I will be announcing our observers of the month. So this is a chance for us to get out and observe. What I want to do next is I want to show you all a couple of locations here. So real quick here, I'm going to go ahead and share my screen. And I want to talk about some locations you can go out and get away from the dark skies. So Mauricio has told us about the Seminole Ranch area, kind of over by Orlando Wetlands Park. Located near Fort Christmas, you can see there's Fort Christmas there off of 50. There is a parking lot. I'm going to go ahead and turn on the satellite view here. This is Orlando Wetlands Park. It is currently open. If you take, I'm going to zoom in even more. If you take this road, it will actually turn to the Orlando Wetlands. If you continue down this road, you eventually get to another parking lot right here. So let me go ahead and zoom in even closer. This whole area here, you can actually park. You can also, there's another parking spot. I think this is actually where Mauricio goes, right here. You can actually pull into here. And right here is a little area you can set up and set up your telescope. So if you're on the east side of Orlando, this is a great opportunity. It's open 24 hours. Great location to set up. There is no power, from what I understand, so you have to bring your own power. But this is a fairly nice dark place. Another place you can go to get away from the stars is Hal Scott Regional Preserve. Hal Scott is located in Wedgefield, right off of 528. You can see here's 528. It's the name of the road is called Dallas Boulevard. You just get off of the toll road, go north a little bit, and you'll see here on the, you'll see right here, there's a parking lot right here. And Hal Scott is also open 24 hours. And as you can see, a nice clear open space to set up your telescope. So I highly recommend that this is another spot that you can go and get away from the light pollution. There might be some light pollution near Wedgefield, but again, you know, this might be fairly dark towards the south. If you want really dark skies and you're willing to drive a little bit further away, you can head to the Herky Bull Creek Wildlife Management Area. And to get to this, it's right off of 192. And you get off, it's this is a kind of a dirt road. I don't know if it actually has the name yet. It's called Crabgrass Road, Crabgrass Road. And you take this dirt road, and Richard, you know, it's a long, long road, isn't it? That was a question, Richard. Oh, I guess we'll never know. But anyways, it's a long, long dirt road. And
I was muted. I'm not good with technology. What can I say? Yes, it was a long, dirty road. I was talking. I got a little box that said, "Hey, you're talking. Do you know you're muted?" That's pretty friendly software. Yeah.
So yeah, so it's a long dirt road, but eventually you get to a spot right over here to the entrance of the park, and you'll see this large dirt pile right here. A couple of dirt piles. It's actually very clear right here. All you have to do is park your car right there, set your telescope up. That right there is a bathroom. So there's bathrooms here. You can even camp there, actually. These are campgrounds. So you can even camp there if you wanted. But right now it's kind of, there's not a whole lot of people there because this is out of hunting season. So these guys are very, very, very dark. Let me, I'm going to see if I can bring up a picture. Let me see if I can bring up a picture real quick of this. Let me see here. I'm going to open up.
While you look for the picture, I'll talk for a minute.
Yeah, go ahead.
For the observing challenge, send your observing forms to Derek what does that mean? Do you have to print them out and email them to him? Mail them to him. No, you can just email them. Most of you have a printer with a scanner. If you do not have a printer with a scanner, most of you have a smartphone. Simply lay it down on the kitchen table and take a photo with your smartphone, and that will be fine.
Yes,
so we'll just do this electronically. Nobody has to actually mail in paper observation forms. You can keep those for yourself. And it looks like Derek found his photo, so I'll show.
Yeah, so this is a view of the Milky Way from Bull Creek, and Richard, you were there, and the skies are pretty nice for the drive.
It was.
And there is no power there, but of course there is plenty of dark skies. So as you can see, there are several places you can go in social distance, get away from people, and observe the sky. So if you need, what I'll do is I'll put together a list with addresses, and I'll post that on Groups.io as well as Facebook for those locations with pins, so you can keep those for reference in the future. So
that'd be great.
Happy observing, and so get out there.
Okay. Well, also, if you wouldn't mind, if you could post your list, Venus, M61, M3,
yes.
M81 and M82 are both in the same field of view with a lot of scopes. I'm going to do those two together. And then the same with the planets and Comet Swan. Of course, Comet Swan's diving behind the sun, so every morning you go, no, not tonight. It's going to get even slightly worse. So we still, it is almost 9 o'clock. This has been it's been a long meeting. I'm going to recognize that. One of the nice things about virtual meetings, though, is we do not have to stop and take a break. All you have to do is mute your microphone or turn off your video, and you can go make a sandwich if you absolutely have to. Plus, we will be posting this video on YouTube as well. But for our main program, Derek is going to also be talking. He's going to give us a demo of a really cool space product called Space Engine. A long time ago, a lot of you remember, I gave several talks at CFAS for a solar system simulator that I worked on, and it was pretty cool. That was a commercial product, and you know how that thing goes. But this is pretty cool. I'm impressed with it. They did a really good job on it, and I'm going to shut up now and let Derek tell you about it. Take it away, Derek.
Yeah, so how we discovered about this software is that when Justin and I have been doing all our virtual field trips, unfortunately, Justin doesn't have access to the UniView software that I have on my laptop here at home. So we only have enough licenses. So we decided to get creative. There have been a couple of times where I haven't been able to give a program, so Justin had to do it in his absence. So we decided that Space Engine was a fantastic substitute for UniView. And in many ways, in my opinion, and Justin, you could speak too if you like about it with your experience with Space Engine, there are some things about this software that I actually like better than UniView, and it only cost $25 to buy the software on Steam. The best part about this is one of the things I discovered is if I paid an extra $25 for the Pro version, which I did, you get fisheye capability. Well, for the average person, that's not a big deal. For me, as a planet, of running this software on the planetarium dome, another feature, another software package to do that. So one of the things that you will see here is right now we're flying over planet Earth, and if I zoom in here, just kind of like our other planetarium software, as we get closer to the planet Earth, we'll be able to get much better detail of the surface. Now, unfortunately, I have the renderings a little bit lower res, just because I didn't want this thing to take 6 hours to process. But what's really cool about Space Engine is if I come down towards the Earth's surface, if everything loads right, you get some incredible three-dimensionality of like flying across the Earth like in space. I think it's just an absolutely gorgeous software. And as I said, right now I have it set to low res, but again, you can bump this thing up pretty big time and get some incredible resolution out of this. But as I said, because of what I wanted to do tonight, I didn't want to kill the machine. But
this is
again,
much smoother. This is much smoother on your computer. It's the internet bandwidth that's causing it to be chunky.
Right. So, but anyways, I didn't want to push it too hard tonight. But again, you have some incredible features just on planet Earth. But one of my favorite places to visit in the solar system is Mars. So what you can do is you can hit this button here, and it brings up your Find Objects, and it gives you all this information. So I can click on this and hit Go To, and here we go, flying to Mars. And just like that, we're on Mars. And what we're going to do is we're going to take a view of some of this interesting spots on the planet. Of course, one of everybody's favorite areas is the Valles Marineris. And one of the things I love about this, hopefully it will load. Hopefully it's going to load here. Please load. There we go. It's loading. This is one of my favorite things to do on Mars. All right, look, check that out. We're gonna fly down, and we're gonna fly. There we go. I'm gonna go ahead and get us. There we go. Whoop. There we go. We're gonna fly. We're gonna fly down to Mars, and we're gonna be able to fly over the Valles Marineris. How cool is that, right? And so it gives it just. I mean, the kids just lose it when we do this, right, Justin? When we actually give them this view of flying over Mars.
Yeah, it's really nothing that we can do that well in Uniview, and the detail on this is just so much nicer.
Yeah, and so you get this incredible view of Mars, and you can still see it's is loading and buffering. So you can give people an idea of just the scale. I mean, I like to tell people right here, you could put the Grand Canyon right there, just the Grand Canyon in that location. People just get really excited about that. So yeah, so that's one of the other things I loved about Space Engine that I did not care about our other software are the ice caps on Mars. One of the things here, I'm going to go ahead and zoom over here. We're going to go ahead and visit some of the ice caps on Mars. The detail on the ice caps on this program are incredible compared to normally, you know, I remember when I was working on that software Seeker with you, Richard. Remember the poles always seem to have that stretching issue?
Right.
Well, this software does not have that issue, and you can fly right down towards the poles and look at it like you're on the Mars Reconnaissance Orbiter. And again, just a stunning detail. But anyway, some of the other things that's really cool. One of the things I really like about this, let's go to the moon of Io. Let's go to Jupiter's moon, Io. I want to show you something that I found really astonishing about Io. It's not really incredible right now, but what we're going to do is we're going to head to the night side of Io. Let me go ahead and do that here. You see those red areas? This has the IR data built into it of the volcanoes of Io. So you can show people that there are volcanoes erupting off of Io. I think that's really cool. And I think this is just a beautiful rendition. You can do screen captures. You can do photos. It just is a beautiful. They did a really great job with the renderings of the software here. Another
you even
one
have on Titan. You can strip away the atmosphere and the. Oh, you were going to look there anyway.
Yep,
yeah, cool.
I'm gonna go. Yeah, you're reading my mind, Justin. We're just that good together. But check out the atmosphere of Titan. Isn't that it just when we use it in Uniview, Justin, it just doesn't have that look, does it? Just doesn't have. You can't see that nitrogen in the atmosphere. But like Justin said, if I turn off the atmosphere and those clouds, you can actually see the data from Cassini here, which I think is really incredible. And you can zoom down here and take a look at the methane oceans on Titan. What's also really neat about this is that you have a exposure control. So you can come down here towards the bottom and you can change the exposure so you can get even much greater detail. So if we zoom down even here, you can see that if I underexpose, you can get more detail here located in the methane pools of Titan, which is really neat. Let's see here. We also, let's go to Pluto. All right, let's go to Pluto. Pluto is fantastic. You have the LORRI data from New Horizons. So if we, well, obviously we're on the wrong side. Let me speed up time here. We can do that pretty well in this software. And again, you have that really nice high resolution LORRI data of Pluto right here. So you can show those details. What's really cool about it is you can tell kids, well, why does this one area look really grainy? It's because when New Horizons flew by, it didn't get high resolution imagery. So you can really teach people how we map planets. So it doesn't just show a fake rendition of another side of a planet. It shows the data. So kids get a sense of, we don't have that complete picture of Pluto yet, so in great detail. So this gives kids a chance to really get a view of that. Deep space objects. Check out the Pleiades. This is incredible. I think this is exciting. All right, so this looks really cool, right? This looks really cool. Oh yeah? Oh, look at that. Sorry, the little things excite me. I think it's just incredible that we can fly in three-dimensional space and show people the three-dimensionality of the Pleiades and where that reflection nebula is. I think it's just really cool to give that perspective of the Pleiades. This also has some really cool volumetric maps. So for example, the Eagle Nebula is in here. So we can fly the Eagle Nebula. So we can zoom in, we can look at the volumetric model of the Eagle Nebula, so we can show people that. I think that's really cool to be able to see that, show people that. We can increase the exposure. There we go. We can increase the exposure there, so we can really get a view of that nebulosity found here in this nebula. So. And we can get a kind of a, now of course this is based off of volumetric data. So if we were to fly around this thing, this is what it would look like. So again, a really neat way of showcasing this. All right, this is one of my favorites. So this is a Sagittarius A. This is a view of a black hole. So obviously my composition is really too high, but I'm going to turn this down all the way. All right, here we go. Check this out. Here we are at a black hole. Talk about some serious modeling here of a black hole. This blew my mind when I saw it. The black hole model that we have in UniView is really junky. But this really teaches people about gravitational lensing and modeling, the shape of a black hole. The fact that it's spherical and the geometry warps correctly based on the way you move it and the lensing effect going on. If you, as you saw there, as you increase the exposure, you can actually start seeing those jets emitted from the black hole. So if we zoom out here, you can see those jets coming off of that black hole there. Pretty cool. Justin, do you have any other places you've discovered and played around with that you think would be really cool to show?
I like showing. I've been showing Betelgeuse to a lot because it shows the nested dust and gas shells of the star, and especially when you're trying to explain the variability of it. The program does a nice job of showing how imperfect this star is. BY Canis Majoris is very similar.
So remember I was talking about the variability of Betelgeuse and how Betelgeuse is getting dimmer and brighter. It's because it has these large excess gas layers that are shedding off of the outer layers of this planet or planet star. And at one point there was a dense haze of this gas that obscured the light from Betelgeuse. I think this is pretty impressive to be able to show people another star like Betelgeuse and some pretty crazy models. One of my favorites is the Ring Nebula. You know, we talk about the Ring Nebula a lot in our outreach, right? We're going to go to the Ring Nebula.
Hey, Derek, does it have any kind of animation feature on there? Because something like the black hole would be incredible.
You know what? We'll do that. We'll do that next. But here's the volumetric model of the ring. People always see this, right? But in reality, the ring is more of kind of like a football. It kind of almost looks like the Helix Nebula. It depends on the way we're looking at it. So I think this is a really cool way of showing.
Yeah, and you can do this, like Derek's saying. I mean, we looked at, you know, Eagle, Crab, Helix, Eskimo. I mean, all of these you can just spin around. It's absolutely fantastic.
Yeah, so you can get that out those outer hydrogen bands of the outermost part of the star, and then you can see that core. So you can teach students and everybody about the fact that you have the hydrogen shells, and you have the carbon shells and other shells that make up the stuff. Now let's go back to Sagittarius A star then, and let's animate it to see if it does anything. I haven't actually done that yet. We're gonna do it, and we're gonna do it live, everybody. We're gonna do it live. You ready? All right. Have you done this yet, Justin? Oh, there we go.
I have. I was doing it with the
Vela
Pulsar, which was a lot of fun.
Bring it down a little.
All right, 1 second.
Sure.
Check that out. Isn't that crazy?
What
did you do, Justin?
Vela Pulsar. Check that out.
All right. Is it just VELA?
Yeah.
Okay, cool. Thank you. We need to start writing all these things down. There's just so much to look at. It's incredible. All right.
Turn the animation on that. You really got to slow it down because it is going quick. But zoom in on that one too, and it's just gorgeous.
And of course, we have to decrease the exposure. There we go. That's pretty wild. Whoop. Look at that. All right, what else do we have? Let's see here.
I kind of Hale-Bopp too. Hale-Bopp was fun.
Oh yeah, Hale-Bopp. Yeah.
There's so much detail on asteroids and comets.
How about a globular cluster too?
Yeah, we'll do that next. All right. Do we have to go back in time, Justin, for this?
I didn't need to. I don't think. You might want to reset time though.
Yeah, because it's not there right now.
Turn your exposure way up too, because
it's dark.
Yeah.
Oh, there it is. Yep.
Yep. Because they were so bright looking at the pulsar.
Yeah. But of course, we have to go back in time so we can get some of the actual dust and stuff.
Since we're not going to see this again until 4030 something.
Yeah, exactly.
So we can go back and
1997.
Yeah, I don't know. Is there that's one part I have. I'm still learning the software, but I didn't know if there was a thing where you can set the time, like in Stellarium. But we'll come back to that later.
Well, if it's got a flux capacitor, maybe you can do it. You know.
Right. Globular clusters. I'm trying to think if there's any globular clusters on here.
M13, Omega Centauri, Toucan.
Yeah. Unfortunately, I don't think they have it listed as Messier 13. You'd think they would have it in here, but
maybe they don't have a model.
Oh, here's a Mau Mau. That's kind of cool to look at. There's a model of a Mau Mau. So you all remember Mau Mau, right?
Yeah.
There it is.
We all know that was actually the Battlestar Galactica cruising through the solar system.
I think, no, Richard, I think it's that monolith from Star Trek 4 that's heading to Earth to
talk to the whales.
Talk to the whales. Ultima Thule's in here. Ultima Thule is in here. That's nice too. So yeah, there you go. You could just have a ball in here. There are spacecraft. Unfortunately, I have it on really low resolution mode. There seems to be some issues with the surface of the moon. Justin, do you ever notice issues with the moon's surface when you do this?
I did visit each one of the landers, or the ones that they had anyway, and it was pretty cool, you know, but I haven't spent a lot of time on the moon.
Yeah, see, I got this weird artifact going on the moon.
I didn't get that.
Maybe that's just
a challenge to five outstanding things on the space engine.
Right, that'd be kind of cool. Yeah, definitely.
We'll do that in the future.
But anyway, so that's the software. That's kind of the fun highlights. We can actually, Saturn's really pretty in Space Engine as well. This actually does have the Andromeda Galaxy. There's Saturn. Again, I like it because it shows the. It's not letting me do.
It's got exoplanets too. I was showing the kids Kepler 1b, and it's got stats on the exoplanets too. So it's just super detailed.
There you go. For some reason, it wasn't attached to the planet, but you can actually see. Look at you got that beautiful storm on the hexagon. Andromeda, it actually has a lot of different galaxies as well. Andromeda Galaxy. There it is. So you can take a look at Andromeda. They're not as exciting, in my opinion, as some of the nebulas and things like that, but it's there.
Which photos of Andromeda are better?
Yeah. This is kind of neat. Let's see, why isn't... Oh, I think I actually have to be in the solar system. Let's go back to Earth. Here's our Milky Way. All right, and I believe, so this is really neat. You can actually fly to different parts of the solar system by just clicking on it, like that. The sun actually looks really cool. You can actually see the corona of the sun. And if you increase the exposure on the sun, you can, it looks like a sun, but you can decrease it. And so that's a nice, neat way. You can, like Venus, or go to Mars, you can fly to Mars this way. Another thing that's really neat, I like, is it shows this right here, the comparisons. So you can also go based on size. So you can actually set up the planets based on size. So I can reduce the exposure here. You can do mass. You can do density. And you can do temperature of all the planets. So you can zoom in and show people, the planets and relating the moons and stuff, relating them and all that stuff. So I think that's a pretty cool little feature as well. So that's kind of a little rundown of Space Engine. A really cool software that you can download on Steam, and that's all just in the box. And they have all these add-ons, and we're just touching the surface on the add-ons. There are tons of community things that people are making, and we're adding more and more stuff to it, and where to play with. So, while we're in quarantine, go explore the universe.
Yes. Thank you, Derek. It's it's really cool how far 3D graphics have come. I saw a video today, a new rendering engine coming out on the PlayStation 5, and it's cinematic. It's cinematic assets. There was a time where if you were doing 3D, you had real-time artists and you had cinematic artists, and the polygon counts were different, and those two worlds are merging because the hardware is getting so fast. So it's pretty cool to see all of this gaming technology being applied to something educational. Which, well, that's, let's not go off on that ramp. So it is after 9. I want to thank everybody for coming out. Let's see how many people made it. Well, we're still at 30 people, probably plus a little with bystanders. So thank you, everyone, for joining us tonight. We will have, I want to remind you that we're going to do our Cosmic Clubhouse on Friday. We're going to just sit around and talk about telescopes. So bring yourself a drink and some chips or a snack, and we're just sit and have a conversation. Also, don't forget our poll for what types of workshops, online workshops that you are interested in, us putting together over the coming months, and we will be putting together another program for next month. And we look forward to seeing everybody there.
Richard,
so,
yes. Can I add a few last thing to mention?
Absolutely.
Somebody did ask. I just want to mention one more time for those that the list for the observing challenge. If you want to go ahead and write those down right now, is M3, M61, the planet Venus. And we also have either M82 or M81 or both if you want to do that. And you can choose one of the 3, Mars, Jupiter, and Saturn. So those are my observing challenges. And I wanted to mention too that for those that are, again, a lot of CFAS members are watching, and we really appreciate you supporting our virtual star parties. And I just want to let you know that Frank and Justin attended a meeting today, and we wanted to do a shout out to both these guys. Frank, do you want to talk about what happened in the meeting today? What's going to happen?
Yeah, it was really cool, and thanks for connecting us with these guys too. So we had a meeting this morning with the Smithsonian, believe it or not, and also the Harvard observatories, and they are setting up a national online star party, not this Friday, but the next Friday on May 22nd. And us humble little CFAS people are going to be a part of it. So me and Justin and Derek are going to be, weather permitting, sharing some views through my telescope in my driveway alongside all these big national observatories throughout the country. So it should be trippy, but it's going to be cool. Yeah, we're going to be going on around 10 o'clock-ish, and we're just going to go around the country showing views from all over the country from various telescopes and various science communicators. So looking forward to it.
Yeah, so CFAS is, we're doing our part to keep everybody excited about astronomy. So I want to thank all of you in support of that. And of course, we love to have volunteers as part of our star party. So if you would like to be featured in a star party, just contact me, Justin, or Frank. We had Barbara Harris on last week, and we'd love to have more of you on and support the program. And
don't forget, we are going to have a CFAS only star party on Saturday the 20-something. I need to bring up my calendar to look at it. The 23rd. 23rd. Yes, we're gonna do our own thing as well. So everybody, get out there and observe. We actually have a pretty nice break in light pollution, somewhat subdued over normal, and we seem to be having some good weather breaks here and there. So take advantage of it and get out there and observe. And I look forward to seeing some observing reports next month. I'm going to do some sketches, and I'm not going to be embarrassed to show them to you. I want to set a good example for just how bad they can be and still be somewhat acceptable. So I will see you all next month. Everybody take care of yourselves and each other.
Question.
Yes.
Post the documents in case some CFAS members didn't attend here, so they have access to the observing document.
Yeah, so I'll be posting that on Groups.io and the Facebook group.
Yeah, and the observing log is on Facebook now, and I'll put it on Groups.io as well.
Fabulous. Thanks, guys.
Okay. Thank you, Eric.
All right, everybody.
All right.